Hello all. In this video, we're going to see another searching algorithm that is nothing but binary search. Binary search is actually an efficient algorithm which is used to find a specific element within an sorted array. And also it works by repeatedly dividing the search interval in half and comparing the target value to the middle element of the interval. This process continues until we reach the target element. So we're going to solve a problem in LeetCode, and let's discuss the question here. Given an array of integers nums which is sorted in ascending order, you should always be clear that in binary search the array will be in the sorted order, which means it is of ascending order and will be given with a target element. Our task is to find whether this target element is present in that sorted array or not. So we are going to write a function to search this target in the nums array. If target exists, then we have to return its index. Otherwise, we are simply going to return -1. So the time complexity of that algorithm is given to be big O of log n, and let's see the examples here. This first example we are given with an array nums which contains the elements -1, 0, 3, 5, 9, and 12, and the target element is 9. The output is 4 because 9 is present in the fourth index of the given array. -1 is zeroth index, 0 is first index, 3 is second index, 5 is third index, and 9 is present in the fourth index of the given array. So 9 exists in nums and its index is 4. The same way, there is an array and the target element is 2. We can see that this target element is not present in the given array, hence the output is -1. So this is what the problem is. So now let us go to the implementation part. We are given with an method search which contains the arguments nums and target, where nums is the array. So our task is to use this binary search algorithm. So in binary search algorithm, we are going to have two pointers. One is called as the left pointer, which points to the leftmost element that is present in the array, and the next one is the right pointer, which will point the last element, the element which is present at the right side. So that will be of the length of the array, that is nums dot length -1. So this left and right is going to store the index of the elements that are present in the array. So we could clearly say that the given array is in ascending order. Then the leftmost element is the smallest element that is present in the array, and the rightmost element is the greatest element that is present in the array, which is the greatest among all the elements that is present. So these are the two pointers, left and right. Once left and right are initialized, we're going to write a while loop. There is nothing but while this left is less than or equal to right, I'm going to perform certain conditions. That is nothing but I'm going to calculate the middle value. So this middle, we used to calculate mid, right? So mid is nothing but left plus right divided by 2. Okay. Now what will this mid variable store? It's nothing but left is actually an index, right is also an index, then mid will also be an index. So this mid will store the middle index of the array. Okay, this is what we're going to do. So we are going to check if my target element is equal to the nums of mid value. If that is equal, then we're simply going to return the position, and the position is nothing but mid. Okay, else if the target element is greater than this nums of mid, it what does it mean? It means that if my target element is greater than the element that is present in the middle value, then we can cut down all the elements that is present in the leftmost side, which are less than the mid value, right? So there is no need to search from the beginning until the mid. So we don't need to search that way. So let us simply assign the left pointer as left pointer will become mid plus 1, and the right pointer will be like nums dot length minus 1. So we are going to search from the mid plus 1 to the rightmost element. Else, what does this else hold? This else is nothing but if the target element is less than the nums dot mid, then we are going to update the right value. So right is nothing but mid minus 1. And if the element is not found, then we are simply going to return minus 1. This is the actual implementation. It's very simple. Now let us run this code. So we could see the test cases are accepted. Now let us submit this. So this is how we implement binary search. Thank you.